Now, we're often finding ourselves in situations where it's beneficial to compare fractions with each other in terms of size and to work out which one might be larger than another or whether they're equivalent to each other. So that's what we're going to look at today. So what we want to start with is I want you to consider if we fill a cup, a half full cup, with the same cup 4/8 full. Which cup will have more liquid in there? So pause this video and give that some thought. Now, what this means, if you think back to what fractions represent, is our half cup is going to be, and I'm just going to kind of do this dodgily, dividing this into 2. All right. And if we divide it into 2 and fill that sort of liquid up, we'll find that a half full cup will have 2 even portions, half filled. On our other cup, we're going to divide that cup into 8 portions. So the easiest way to probably do that is to go there, there. Kind of regretting choosing 8 now. Pretend I've amazingly divided this up perfectly into 8ths. I think that's 8. 1, 2, 3, 4, 5, 6, 7, 8. Yep. 8 segments, and we're going to fill 4 of those segments up. So 4 segments is right there, and we're filling this up with liquid here. And what you should notice is the cups, if I drew them well, which they're looking at each other, they're not, the cups should be roughly equally filled. In fact, they should be exactly equally filled because 1/2 is the same as 4/8. Now, an easier way to see this, rather than relying on my dodgy handwriting, is to look at our 4ths and our 8ths on our fraction rule. So if we look at this and we find our 4ths, our halves, sorry. All right, halves are just here, and we find that of our whole, it gets halfway exactly, just to there. When we look at 4/8, well, our 8ths are in here and we've got to colour 4 of them in. What you should notice is we are colouring the exact same amount in of the row as each other. And it's because they represent the same quantity. So what we can conclude from this is, back on our original question, is 1/2 is the equivalent meaning equal, to 4/8. All right. Now, this is really, really important because we need to be able to compare quantities. And there are times where we want to get the same, to do that, we need to get them roughly to be the same sort of base so we can compare it to. But what I want you to notice is I can actually convert from one to the other by multiplying the top of a fraction by the same number as I multiply the bottom of the fraction. So if I multiply the numerator here by 4 and the denominator here by 4, I get to an equivalent fraction. And this is true for all fractions. If I multiply the same to the top and the same to the bottom, we can get them to be equivalent to each other. However, fractions aren't always equal to each other. Sometimes there is a difference. All right, so sometimes we might have a half full cup and a 4/7 full cup. Which one's going to be more full now? Pause the video and have a think about that. So to do this, rather than rely on my dodgy drawings, although I could do it, all right, a half full cup we know is, do I have the pen or the highlighter on? A half full cup, we divide it into 2. And it's that sort of portion just in here. The 7ths, well, we'd need to divide it into 7. I don't know how I'm going to do this well. 1, 2, 3, 4, 5, 6, 7. All right, let's hope that that's good. All right. So on this one, we've got 4/7. So 1, 2, 3, 4. we can have a look at that equivalence just in here. And what we should see, if I've drawn this really, really well, which I don't think I have, we should see, hang on, I've gone the wrong way. We should see that this one's slightly more full than this one. Okay, and I don't think I've really shown that too well. Let's look at a fraction rule so I can show it a little bit better. Now, the reason for that is when we look at our sevenths and we add 4 of these together, it ends up being more than half full, all right, compared to that quantity down in here. So how do we actually tell that without relying on visual information, without actually getting the same, I guess, getting it onto a wall like this, a fraction wall, something like that? Well, to do that, we actually need a common denominator. All right. So when we're looking at our sevenths here, we need to see if we can get this number here to be the same as this number here. Okay. Now, to do that, I've got to think about, well, what is the lowest common denominator between those two values? Well, in this case, the lowest common denominator is going to be 14. So the first thing I need to do is go, okay, well, how do I get a half to have a denominator of 14? Well, to do that, I need to multiply this by 7. All right, but whatever I do to the top, I need to do to the, to the bottom, I need to do to the top. So if I multiply this by 7, that gives me 7/14. Now, I'm doing this so I can compare the two quantities. So I've got 4 sevenths, all right, and I want this to be with a denominator of 14. Oops, not 17. 14. And I've got to look at this and go, well, how do I get that to here? Well, I'd multiply it by 2, which means I need to multiply this by 2, which gives me 8. And now we have the equivalencies. So a half is equal to 7/14. A 4 on 7 is equal to 8/14. And we can see that more is going to be in this cup than is going to be in this cup. Okay? So essentially when we're comparing fractions with each other, we need to have a common denominator to do it. So we convert the two fractions with a common denominator, and then we can look at the numerators to see which one's larger, determine which one is going to be the larger or smaller value. Now, that brings us to simplifying fractions, because there's often fractions that we find that we need to simplify. And in maths, we tend to represent fractions in simplest form as a default. Now, because we can multiply the top and bottom number by any value and we'll find an equivalent fraction, we can also do the reverse. We can divide the top and bottom number, the numerator and denominator, by the same number and find an equivalent fraction. So what we want to do whenever we have a fraction such as 6/14, we want to look at what is the largest number that divides into both 6 and 14. The largest number, all right? In this case, it's going to be, 2. So what we're going to do is we're going to divide the top by 2 and the bottom by 2. The numerator divided by 2 is going to be 3. The denominator is going to be 7. And we find the simplest form of this is 3/7. Now, we can apply this with every sort of problem. So if we've got 15/45 and we want to represent this in simplest form, we want to look at the top number and go, what's the largest number that can divide into it? Now, yes, we could divide 5. That does divide into both. However, there is a larger number, and that number is 15. So if we divide the top and the bottom by 15, it goes into the top once, it goes into the bottom 3 times. We find that 15/45 is the same as 1/3. Now, whenever we're dealing with simplifying fractions, I often see people try to simplify something like 18/6, and they correctly identify that, hey, 6 is the largest number that divides into both. They're correct. Okay, it goes into 18 3 times, it goes into the denominator of 6 once. But I also want to think about, if we're representing something in simplest form, well, representing a whole number, because 3 divided by 1 is equal to 3. Representing a whole number as a fraction isn't really the simplest way to represent it. The simplest way is to represent the whole number itself. So while you are simplifying fractions, you should also check, does that division actually work? So does 6 go into 18 perfectly? If it does, then just write what the whole number solution will end up being.